Hello and welcome to this GibbsCAM Tech Tip. In this video, we will take a look at using the profiler in cylinder profile mode to create polar and cylindrical, also known as rotary, toolpath on a solid model. This model has a simple closed cylindrical cam, but the same technique that we're going to look at also applies to open cylindrical cams, slots, pockets, and other feature types that need to be machined using polar and cylindrical toolpaths. These are toolpaths where the cutting tool remains centered on the rotary axis. It's also known as axis substitution since the rotary moves are substituted in the place of one of the linear axes. In this case, I'm running this part on a vertical machining center with a rotary axis, and the rotary axis is aligned to my X. So in this case, Y-axis moves are replaced with A-axis rotational moves, wrapping the toolpath around the rotary center line. To create this toolpath, I'll make sure that my part is oriented correctly and that I have my CS1, or my world origin, at the center of rotation. I'll create my pocket using tool 1, a 1/2 inch end mill, doing roughing, and I'll set my parameters. I'll set my speeds and feeds for roughing. I will eliminate the lead in, lead out move. I'm going to leave a little bit of stock. This is a 6-inch diameter part, so the top of the material is at Z3, and the pocket is a 1/2 inch deep. So the groove is a 1/2 inch deep, so the bottom of the groove will be at 2.5 inches. I'm going to do this in 1/8 inch steps just to create some toolpath. And I'm going to helix in. And I usually start my helixes with a 1/2 inch end mill. My starting point, at least, is starting 10 thousandths above the material with an 80 thousandths pitch and a 60 thousandths per inch slope, which gives me just about 3.5 degrees of down feed. And I've got a little bit of wall clearance here to keep the tool away from these walls while it's helixing. The last thing that I want to do is go to my rotate tab and make certain that polar and cylindrical milling is checked. This is the command that tells GibbsCAM to wrap this toolpath around a cylinder rather than trying to create the toolpath as flat toolpath. I'll follow that up with my finishing tool, doing a contour, and I will set my speeds and feeds for finishing. I will give it just a little bit of a lead in and lead out move, line and radius lead in and lead out. I'm going to go to finish size. My Z's are correct. I want to do this in one pass. Auto plunge is fine for my entry. And I'm going to go to my rotate tab and make certain that polar and cylindrical milling is checked. All right, now to define what's going to be cut, I want to use my profile. So if we look at our profile drop down, we have 4 different types or styles of profile or modes of profiling that we can use. We have a slice plane profile, a spun body profile, a silhouette profile, or a cylinder slice profile. Cylinder slice profile is what we're going to use for this. Now, if you look at the profile, the cylinder that's created, it's oriented incorrectly. And the slice cylinder profile is always aligned to the depth axis of the active coordinate system. So to align this properly, I need to create a temporary coordinate system that I'm going to align to the right end of the part. So that's the YZ plane. And that gives me this profile. Now, just like most of the profiles, I can grab the edge and drag it to manipulate the profiler. In this case, the green cylinder is smaller as I move it toward the origin. We'll roll that around a little bit so we can see it better. And it gets bigger as we move it away from the origin. Since this groove is what I'm machining, I want to increase the size of this until it's intersecting these walls, which I can then select these two walls and create my toolpath. So if we reorient this and run our simulation, we have good toolpath to rough and finish this shape cam slot that was wrapped around a cylinder on a solid model. And we didn't need to extract or unwrap any geometry to do it. So in this video, we took a look at using the cylindrical profiler to identify wrapped features on a solid model, as well as using those features to create polar and cylindrical, also known as rotary or wrapped toolpath on this feature. I hope you find this information helpful. There are often a lot of opportunities to use this on machines with a rotary axis. If you have any questions about polar and cylindrical toolpaths, either using geometry or solid models, or any questions about using any of the profiler modes, or for that matter, any other GibbsCAM related questions, please reach out to your GibbsCAM reseller.